Okay, so the last thing we want to talk about in this section of notes is all the different types of answers, of solutions that you can get for a system of equations with two equations and two unknowns. So what we've seen so far is the unique solutions in what's called a consistent system. So that's when you find one point where the two lines cross, and that is your answer to that system. There are two other forms that a solution can take. One is infinitely many solutions, and that's called a dependent system. What happens there basically is that the equations can be written as the same line. So one line is just a multiple of the other line. And when you simplify it, it turns into the same line. So where do they cross? They cross then, if two lines lie right on top of each other, they cross at every single point on that line. So infinitely many times. The third solution that you can get is you can get a no solution, an inconsistent system. That's when the equations have the same slope but different y-intercepts. They're parallel. Parallel lines. Where do they cross? Never. They never cross. So those are the two other types that we can have. So let's look at how those work when we're trying to solve them. So in this first case, I know we've got some decimals there, but this is set up really great for that addition method because they're both in the standard form of x plus y equals a constant. So what I'm going to do here is I am going to get creative, and what I can figure out is that if I multiply this second equation by 0.6, I can actually turn that y into its opposite, right? Because this already has a 1. So what I'm thinking here is I just need to turn this then into a negative 0.6, and then these will be opposites and cancel out. So that's what I'm going to go for here, is canceling the y's. That means nothing at all happens to the first equation. Then what I get here, when I take 0.6 times 3x, I get 1.8x. I get negative 0.6y, and I get 6 here. So I did achieve my opposites here. I'm going to add those together, and those are going to cancel out. But accidentally, in the same process, I also canceled these out. So I have nothing at all. I have a big fat 0 over here on the left-hand side, but on the right-hand side I have 12. So I have now arrived at the situation where I'm claiming that 0 equals 12. That is false. 0 does not equal 12. So when your variables all drop out, but you are left with a false statement, what this means is that you have a no solution situation. And you have parallel lines. And we'll graph that in just a second to see it. Let's look at this other one first before we go down and look at the graphs. So on this one, it's actually set up pretty nicely for substitution. I'm just going to take this equation and sub it in here for y. So let's see, we've got 2x minus 5, and in place of y, I'm going to write 2/5 x minus 2 equaling 10. Distribute. The 5's are going to cancel out there, leaving us with negative 2x. That's a positive 10 equals 10. The x's cancel each other out, so we get 10 equals 10. In this case, again, all of the variables dropped out, but what I was left with was a true statement. When it's true, we have infinite solutions. Now be careful, don't say infinitely, don't say all real numbers, because these aren't just numbers, these are ordered pairs. So instead of saying that, we just say infinitely many solutions. So it's all of the solutions that are on a certain line. I'm going to wait again just a second, and we're going to graph that first in order to see how we need to write that final answer. So let's go down. Can I keep this on the screen just barely? Maybe, while we graph these. So let's see. Graphing this first set, I would have to first rewrite them all solved for y. So I'm going to skip that. You can do this part on your own. Rewritten, solve for y. This one up here comes out as y equals 3x plus 10. And rewritten solve for y, this one comes out as y equals 3x minus 10. So if I want to graph that, when the first one says start up at 10 and then go up 3 over 1, I run out of graph to try to do that. So instead I'm going to go down 3 and backwards 1. And I'm just going to do it in reverse. You're allowed to do that as long as you do both in reverse. So that line is here. And the other one says to go down to negative 10 and then have that same slope. So pull it up here. So negative 10 and go up 3 over 1, up 3 over 1, up 3 over 1. And what you can see is that those do indeed come out as parallel lines. Where do they cross? Nowhere. That's why we don't get any solutions. Okay, the second one, what happens when it comes out as infinitely many is, again, what that's telling us is that both of these are actually the same line. If we were to take this line up here, this top line, and solve it for y, it ends up being this. It ends up being that line. So they're the same line. So we want to graph that line. So I want to start down at negative 2 and then go up 2 and over 5 and run out. So it looks like this. And that's it. So where do these two lines cross? Because technically it's another line also drawn right on top of that. So notice they don't cross at every point. Not every single point, right? This point is not a solution, and this point over here is not a solution. So we have to somehow note that it's all of the solutions, but only the ones that actually fall on that line. How we do that is we let there be a parameter. So this is kind of maybe new from your algebra class, this part. So what we do is we say let x equal t be the parameter. Okay, so what kind of points lie on this line? The points are of the form if I pick some x value, and we change the variable to t just so that it's clear that it's what we call a parameter in this case. If we're free to choose any x value, the y that matches with it has to be of a certain form, and the form that it has to be of is the formula in this line. So if I pick any t to find its matching y, I have to do 2/5 times that value minus 2. So I can't just pick a t value, let's say, of 0, and then pick any y to match with that, because 0, 0 is not a point that works, and 0, 1 is not a point that works. Only the point 0 matching with 2 is the one that works. Well, how would I arrive at that? I would sub a 0 in, and then I would do 2/5 times 0 minus 2, and I would arrive at the idea that 0, negative 2 is a point that works. Then I could do that over and over again, right? So it's just using the equation that both of these lines turn into in order to find more and more points. So really the key, or why do we care about this, is because sometimes people misunderstand when we get a true statement here and we say infinite many solutions, that we don't mean all points. It's weird that there's a difference between infinite many and all. So we have infinitely many solutions on this line, but it doesn't mean that the entire coordinate plane, all of the points in two-dimensional space work. That's why they like for us to give this formatting right here where we say, no, wait, it's not all points. It's just points that have this specific format.